So let's jump into task 6.1 for module 6, iOS MTP. Again, provision both the corporate headquarter router and branch 1 routers to support MTPs for up to 50 concurrent sessions. Don't use any DSPs, and enable support for both RSVP and trusted relay point. So we'll bring back up our router session here. And we were in the middle of configuring our MTP. Now, we weren't instructed to, but this is something that we could certainly ask the proctor about. It would probably go, I don't know about without saying, but it would certainly be logical that because these are between router 1 and router 2, or between headquarter and branch 1, that we will most likely need to provide the codec for G729. Okay, again, this would be a clarification task for the proctor. In this case, the proctor, myself, would say, yes, we want G729 as the codec across the WAN. So we're going to say no codec for G711 and codec for G729. Note that if we, and it's ambiguous because we have multiple flavors, AR8, ABR8, BR8, and R8. By the way, the R8 stands for rate 8. Okay, so the default codec bit rate of 8 kilobits per second with no headers. So the AR8 is the Annex A, BR8 is Annex B, AR8 is Annex A with support for B, which is bad, A being the lesser complexity, and R8 just being the straight high complexity G729 R8. Now, although you can get R8 to work just fine, the Cisco endpoints actually speak CUCM IP phones, 7900 series, 8900 series, they actually speak the Annex A, the lower complexity. But it tends to be fine just to enter R8, or we could do AR8. Okay, so notice if I tried to do a show run here real quick, if I tried to do a codec G711 MULA, it would tell me that there's already a codec configured and it's not compatible with the codec for this MTP service. So let's see if it would let us enter AR8, for instance. It does allow us to enter multiple different variants of the same codec. So AR8, ABR8, R8. We also have the ability to enable RSVP support. So it's very simple, just RSVP enter. And then also TRP, or Trusted Relay Point support. And we have to enter the firewall traversal command. Okay? Using stun, or the tunneling. So now, again, let's just do a look at this. We've got support for RSVP, support for Trusted Relay Point, 2 G729 variant codecs, and now we can no-shut this. However, it says we have to configure the max sessions. Okay, so let's say maximum sessions, and we can choose here hardware or software MTP. We want to do it in iOS. We were told no DSP resources. And then the number of sessions, we were told 50. But now when we try to no-shut it, it says that we still have to associate the profile to an application. So we use the associate command, and we want to associate to the application of the skinny protocol. Now we can no-shut it. Of course, it's not going to register until we actually configure our SCCP command, so let's go ahead and do that. So first, we've got our skinny local command, which binds the skinny protocol to a local interface. Probably loopback 0 would be the best. We need skinny enter to turn it on, but we won't do that right away. We need to specify SCCP CUCM, and we have both the group and the host name. Okay, so first of all, we need to specify host name, or in this case, IP address. So 177.1.10.20 is our subscriber. We have to specify the identifier, we'll call it 1, and the priority of 1, and then the version. We could just go ahead and say enter, but, and depending on the iOS we're running, I was actually fooling around with an older iOS, so this only shows, oh, nope, actually I am running iOS. So if the iOS only supports 501, an older one, like let's say 12.4.15, only supports 501, then you can just use 501 as long as it is the Linux-based CUCM, 501 and better, then it will work to register to 6 or to 7. Of course, if you actually have the iOS that supports, in this case 7, and that's what we're using, then it's probably best to use that iOS. Okay, we'll also say SCCP, CCM of 177.1.10.10 as an identifier to priority to, again, version 7. Okay? Then we can enter our SCCP. Now this used to be fine. In terms of identifier, we still need that. In terms of priority, this actually used to be used when we did just our DSP transcode, DSP conference bridge for the older PVDM1 or Gen 1 PVDMs. That's where the priority bit came in. Okay? For the newer PVDM2s and 3s, we create SCCP CCM groups. Create group 1 here. And we associate both profiles and CCM identifiers. So we'll associate the CCM identifier of 1, which we earlier specified was the sub, identifier 1. And here we'll specify priority again, but this is actually the one that matters. Again, the other priority only mattered for the older PVDM Gen 1s. And then we'll associate CCM 2, identifier 2, with priority 2. We'll also associate the profile 1, which was what we created for our MTP DSP farm profile, and we'll tell it to register to CUCM as a device name with a max 15 characters. So this is important that we key it in the same way in both places. In the original Gen 1 PVDMs, we actually had to tie it to a MAC address, which means we had to tie it to an Ethernet or fast Ethernet interface. That limited us. Couldn't use a loopback because loopbacks don't have MAC addresses, and therefore we didn't have the redundancy. So this allows us to not use MAC address, but rather to use whatever name we want. So let's call it corporate headquarter MTP. Let's actually call it software MTP, so that we know it's not a hardware DSP just by the naming when we register it to CUCM. So now let's do show run pipe to section skinny or DSP farm and see what we have here. We've got our local loopback interface for traffic sourcing and destination. Destination if it's coming to us, source if we're originating the traffic back. Our 2 CUCM identifiers, associating those in the group, associating the profile 1 to register as this name. The profile is no shut with a max sessions and associated to the skinny application with the proper codecs, RSVP, and TRP support. All we need to do now is say SCCP, turn it on, and we can do show SCCP. Now we notice that it's active in progress, not registered with CUCM. TCP link status is not connected. There's no active call manager. Okay, we can sit here and do this for a while. Eventually it will stop trying and fail. And this is because we obviously haven't done anything on the CUCM side. So let's bring that up. Okay, we'll log in to the CUCMA and go to Media Resources and there, Media Termination Point. We note that we already have 2 MTPs, probably useful. These were from the software IP voice media streaming app, one for CUCM hub and one for the sub. So let's call them that. So that they are easily distinguishable. Okay, we can see the IP address, host server. Now, keep in mind, and it's resetting. that just because the MTP resides on the host server of .10, the pub, or the host server of .20, the sub, that doesn't mean that's where they're registered. They're actually both registered with .20. Why? Because their device pool, corporate headquarter, specifies a primary CUCM group, and this CUCM group is named appropriately sub_pub. And if we actually look at this group, it does in fact state that the sub comes higher ordered than the pub. So that's why these software media termination points, also the conference bridges we'll look at, are all registered with the sub, even if they happen to be running on the pub. So when this becomes important when we're looking at RTMT statistics to ensure that we know where those resources are registered, so we know which server to point our perfmon counters at. So we'll add a new MTP. This is going to be an iOS enhanced software MTP. And what did we call it? We called it type 2 section skinny or DSP farm. Oops, put a comma in there. So I didn't get the DSP farm bit. That's okay, it's under skinny. We called it that, so that's what we have to copy and paste in. Register it to device pool corporate headquarters, and it is a trusted relay point. We'll save that, reset it, find list, and we see currently it's rejected, and there we go. And now it's finally registered. Now it's registered with the pub. There we go. First it registered with the pub, now it's registered with the sub. Now it's registered properly. We go back here to iOS and do show skinny. We see that it's active. There's no cause code, which is good. Cause codes are typically bad. And we see which CUCM server it's registered with, it's connected, RSVP is enabled, everything's good. Okay, so we've met task number 1 to get our MTP up and working.